In an exothermic reaction, heat is evolved and system loses heat to the surrounding. For such system, देखो system ना heat lose कर रहा है, it's actually losing the heat. So obviously हमारा जो heat होगा QP, it will be negative, and enthalpy of reaction will also be negative. Since it is an exothermic reaction, so enthalpy of reaction will be negative, QP will be negative. For example, carbon, which is in the solid state, plus O2 in the gaseous state, gives us CO2 in the gaseous state with the evolution of, suppose if I'm just talking about 393.5 kilojoule. Fine, so QP is the heat lost, so it will be negative. Enthalpy of reaction, energy of reaction, yes, so it will also be negative basically. Fine, so you might have a thing into your mind कि if I just talk about कि QP और डेल्टा H ऑफ द रिएक्शन के बारे में अगर मैं बात करती हूँ तो हमेशा याद रखना फॉर एक्सोथर्मिक रिएक्शन एंथैल्पी चेंज इज नेगेटिव. ठीक है, एंथैल्पी चेंज इज नेगेटिव. फॉर एक्सोथर्मिक रिएक्शन मैं यहाँ लिखना चाहूँगी फॉर एक्सोथर्मिक रिएक्शन एंथैल्पी चेंज फॉर द रिएक्शन इज नेगेटिव. दिस इज एंथैल्पी चेंज. This is enthalpy change basically is negative. ठीक है, and QP is equals to enthalpy change for the reaction at constant pressure. QP, heat at constant pressure, is equals to what? Enthalpy of reaction. Fine, it's at constant pressure we are dealing up with. Yes ma'am. Okay, so delta QP, if I just talk about delta QP, it will be also be negative. Since in this question it is mentioned कि ये एक exothermic reaction है, so QP and enthalpy of reaction will both be negative. Option 1 and 2 are the right answer to the question.